The quotient rule serves the same basic purpose of the product rule. It allows us to take the derivative of a more complicated function. And this allows us to take the derivative of any quotient function. So again, it's just a matter of recognizing the pattern and following it. So I will go ahead and use this pattern. What I will do is color code it with the top being in red so you can see my work as I'm doing it. And the pattern says when I take the derivative of a quotient function, I will take the derivative of the top first, and I will multiply that by the bottom, minus the top, just like it is, times the derivative of the bottom, all over the bottom squared. Now, I will simplify this a little bit by using my distributive property and combining all like terms. So just going down, distributing that 3x squared, and I get 3x to the fourth minus 21x squared minus, I'm going to distribute the x cubed, 2x to the fourth, all over the bottom squared. Now my goal is to put this in factored form, and since the denominator already is in factored form, then I will leave it alone. So I'm going to combine like terms. 3x to the fourth minus 2x to the fourth is x to the fourth minus 21x squared. Again, the denominator is not affected. And I will factor out my greatest common factor, which is x squared, leaving me x squared minus 21 all over x squared minus 7 quantity squared. At this point, I will determine if there's anything in the numerator and denominator that can be reduced. There is not, so I am done. Now, this may have looked a little bit complicated. However, really important to understand that nothing below this blue line is calculus. One step and only one step, and that was following the derivative pattern, was calculus. Everything else are properties of basic algebra, how to reduce a rational function. What you want to do is simplify and factor the numerator and denominator. Okay, so just like before, we can apply this technique to graphs. And this time I want to estimate the derivative of u at 1 given u of x equals f of x over g of x. So again, I'm going to write my pattern out real quick. U prime of x equals f prime of x times g of x minus f of x times g prime of x all over g squared of x. First thing I'm going to do is plug in my 1 into that formula. Okay, so I'm going to need to identify some locations and slopes of tangents when x equals 1. So let's find x equals 1, find some locations, and some tangents. So let's move this over. U prime of 1 equals f prime of 1. Now for this, I'm just going to go ahead and zoom in, do my best to draw a tangent line. Again, it's an estimate, so I'm looking carefully, just drawing the best line I can draw. That appears to be tangent, And I'm going to go with, there it is. Again, it's an estimate. It's not an exact amount, but I'm guessing that the slope of this tangent line is, let me scoot that over so I'm not writing on it. The slope of the tangent line, it's definitely negative because it's going down, and it appears like it is negative 2 here, down 2 over 1. Again, it's an estimate from straight lines from a graph. So I'm going to estimate that slope to be negative 2. Times g of 1, and g of 1 appears to be 1.5 or 3/2. Oops. And I should probably put here an estimate symbol just to be accurate, because we're not finding the exact value, we're estimating its value. Minus f of 1, okay, that's 1, 2, 3, 4 is my output, times g prime of 1. This slope here, let's see, it's a straight line, so I just need to calculate a rise over run. It appears the slope of that line, which is the piece of g, is 1/2. All over the output of g at 1, which we determined was about 3/2 squared. Now, generally, I would say since this is an estimate, you could go ahead and put it in a decimal approximation, but I'm going to go ahead and simplify these fractions out myself. So I end up with negative 3 minus 2 all over 3/2 squared, which is 9 over 4. So this leaves me negative 3 minus 2 is negative 5 divided by 9/4, but I do not divide by fractions. I multiply by their reciprocal. That's a times, not a, let's just make it a nice, pretty little time symbol so you don't mistake it for an X. And again, this is just my approximation, but it's a reasonable approximation of my answer. So I had to use some basic skills that go all the way back to Chapter 2, Section 1, where I had to, and that's why I made that part of our lab, where I had to make a tangent line on the graph itself to estimate the slope. So, quotient rule.